Let's talk about the invisible force that connects your smartphone, your medicine, and even the clean fuel that could power a jet engine. That force? It's chemical engineering. And honestly, it's the hidden architecture behind our entire modern world.
So really think about it for a second. What on earth is the link between the medicine in your cabinet, some new kind of jet fuel, and the phone in your hand? They feel totally random, right? Well, it turns out there's a really powerful common thread that ties them all together.
And the answer, the big secret, is a mastery over one single idea: process. This is the absolute heart and soul of chemical engineering. It's the art and science of taking something raw and transforming it into something, well, extraordinary.
So at its core, chemical engineering is all about designing these complex processes that turn raw materials, we're talking plants, oil, sometimes even waste, into all the products that pretty much define our lives. Seriously, think about it. From your shampoo and lotion to paper and gasoline, a chemical engineer designed the process to make every single one.
Now, you might hear the terms chemical engineer and process engineer thrown around, and they are super similar, but there's a key difference in focus. A chemical engineer, they're laser-focused on the chemical transformation itself, designing that core reaction. The process engineer, on the other hand, kind of zooms out. They're looking at the whole production line, including all the mechanical and electrical stuff, to make the entire operation safer and more efficient.
Okay, so they're masters of the process. But what are chemical engineers really doing with that skill? Well, they are on the front lines, tackling some of the absolute biggest challenges our planet is facing right now. And this is where it gets really exciting. I mean, the impact they're having is just incredible. You've got chemical engineers designing plants that can turn canola oil into sustainable jet fuel. Others are developing plastics that won't choke our oceans. They're finding ways to pull valuable stuff out of industrial waste. And this one is so important. They're the ones who figure out how to take a new life-saving medicine from a tiny lab discovery to millions of doses. This is engineering with a truly global purpose. You know, this quote from Michelle Hanoun, a student at UNSW, just nails it. It's not just about mixing chemicals in a lab. It's about using that knowledge to solve huge, critical problems in energy, food, health, and the environment. But here's the catch. To solve these massive problems, you have to design these unbelievably complex processes. And traditionally, that whole design phase has been a huge bottleneck. It's slow, it's manual, and it's just incredibly painstaking work. Just look at the old way of doing things. An engineer starts with a cool concept, and then they have to spend weeks, and I mean literally weeks, manually plugging in hundreds of parameters just to build a model they can test. And what happens if that simulation doesn't work? It's all the way back to the drawing board for more time-consuming tweaks. This manual grind has been holding back innovation for years.
But what if you could just break that bottleneck? This is where the story takes a really dramatic turn. We're talking about the AI revolution, and it is completely changing the game for how these processes get designed.
And this is the new way. So instead of weeks of manual grunt work, an engineer can now just type in a simple text description, something like design a process to separate benzene and toluene. Then, this sophisticated AI workflow takes that simple request and automatically turns it into a complete, validated simulation model. It's incredible.
So what does this actually mean in the real world? A staggering 89% reduction in design time. Just let that sink in for a moment. A task that took a human expert over 2 hours can now be done in about 15 minutes. But look, this isn't just about saving time. This is about buying more chances to innovate. It means more attempts, more experiments, more what-if scenarios that were just impossible before. It's about speeding up the pace of discovery itself.
And it's not just about being faster. It's about being smarter. Okay, on the left, you see a design from a standard general-purpose AI. It works, but it's pretty basic. Now, look at the design on the right from the new multi-agent AI. See that extra loop at the top? That's called a reflux stream. It basically recycles material back through the system to get a much purer final product. It's a smarter, more practical, and way more economically viable design. This shows the AI isn't just following instructions, it's actually thinking like an experienced engineer.
So how does this whole thing work? Well, think of it like a specialized team of AIs, which is why it's so much better than just one general AI. You've got one agent that's an expert at just understanding the request. Another one is like a master architect, designing the whole layout. A third is a numbers whiz, calculating all the complicated parameters. And then the final agent acts as quality control, checking if the result is any good. When you get these specialists working together, you get a much smarter, more robust result. So with these mind-blowing tools just around the corner, let's bring it back to the engineers themselves. What does a day in the life of a chemical engineer actually look like? Because it is way more diverse than you probably think. Yeah, forget the stereotype of someone just stuck in a lab coat all day. Chemical engineers are literally everywhere. They're working with doctors on processes happening inside the human body. They're designing massive manufacturing plants for food and aerospace. You'll find them in steel mills and cement plants, making these essential industries way more efficient. They are at the heart of making, well, almost everything we use.
So what's it really like on the ground? Well, as one engineer in the polymer industry put it, their job is to tell people what they're doing wrong and get to do the fun solution and design. I love that. It's all about being that high-level problem solver who can spot the issue and then create the fix. And that deep expertise can sometimes feel like a superpower. This quote is hilarious because it highlights that when your knowledge is so specialized, explaining why something works can be so complex that to everyone else, it just looks like you're practicing black magic. But beyond all the technical wizardry, what makes the job truly rewarding? This insight from an R&D engineer just hits the nail on the head. Satisfaction isn't just about the task itself. It's about the creative freedom and the autonomy you have to solve problems your own way. So, as we start to wrap this up, think about what we've got. We have these brilliant, creative engineers who are solving the world's biggest problems, and now they're about to be supercharged with AI that can slash their design time by nearly 90%. This brings us right to the edge of the next frontier. And this is the big question I want to leave you with. When you automate that slow manual design process, you don't just make things faster. You open the door to creating entirely new materials, new medicines, and new energy solutions that were once just too complex to even try. The future isn't just being manufactured anymore, it's being designed right now.